Hey, welcome back. We're finalizing some basic ideas of probability. So here are the things you need to know. Probability model. Probability model has a couple of components that you must have. And by couple, I mean literally two. You need to make sure, first of all, that you list out all of the possibilities. So it's very clear that you haven't overlooked anything. Okay. So you're going to list out all the probabilities and their outcomes. The two things that all of these probabilities need to have happen is they must add up to be 1. If it doesn't add up to be 1, you're missing something. If it adds up to be more than 1, you counted something twice. Okay, because we're talking about all the possibilities. If we're talking about everything, that's 100% of the options. Okay, so the probability of each separate event is going to be between 0 and 1, because think about what's going on. If everything added up to be 1, you can't have a negative probability because you can't have the probability. I mean, either it happens, you can have probability that something doesn't happen, but you can't go lower than that. So each of the individual probabilities have to be between 0 and 1. There are 3 different types of probabilities you need to worry about. The first one is called complement. A complement is the probability that an event is not happening. Okay. The benefit of knowing this is it can actually save you a lot of time. So like here, the probability of A complement, which is A not happening, is 1 minus the probability of A. I mean, you're basically dividing into 2 groups. Here's the probability of A happening. Everything over here is A not happening. So you're either in one group or the other. Okay. Either you live with both parents or you don't. It's kind of what you're in one group or the other. There's not like no. Okay. Mutually exclusive events cannot occur together. Okay, this is not always going to be the case, but for right now, when we talk about things being mutually exclusive, that means that you're in one group or the other. You can't be in both. And then the general addition rule, and this is for mutually exclusive events, otherwise known as OR, is that if I'm asking for the probability of A or B, you're just going to add up the probability of A and the probability of B, and then you're done. All right. So if we go back to the previous page here, just so you know, and we haven't actually talked about this, okay. This right here, when we were doing the data, okay, so we were rolling the dice, etc., that was called experimental probability. Probability. Okay, this is what we saw, this is what we experienced. This is what we did in an experiment. This down over here, where we just think about it, is theoretical. Okay, so those are going to be 2 distinctions that's going to be good to know. The theoretical probability down here is what we use up here in terms of setting up a probability model. What are the options? What could happen? All right. So we got to check your understanding. Talking about family size from the Pew Research Center. Take a second. They're pretty easy. Hit pause, do them, come on back. All right, so the Research Center went through, they randomly select one mother from ages 40 to 44 and record the number of children that she has. Here's your probability model. So what we found from this data, this is going to be experimental or theoretical. Okay, experimental. This is the 4 different numbers that we had. Why is there not a 0? Because they selected a mother. I only say that because somebody always asks. So down here, the question is, why is this a valid probability model? Remember, they must add up to be 1. Probability must be between 0 and 1. So each probability is between 0 and 1. Yes. If I add up all 4 of these numbers, you're going to get the answer of 1. So we're good there. Explain why having 1 child and having 2 childs are mutually exclusive. You can't have exactly 1 child and also have 2 children. Okay. The events cannot occur together, so therefore, by definition, they are mutually exclusive. You either have 1 child or 2 children, not together. Same thing with 3 and 4. So, some probabilities here. Find each of the following events. So what's the probability that you're having less than 2 children? So that's another way of saying less than 2 children would be having 1, because I want numbers less than 2, not less than or equal to, so that's just going to be the probability of 1 child. Yes, you should probably write this out so it's clear to the reader, the grader, whomever, that you know what you're talking about. 22%. What is the probability that a selected mother has 1 or 2 children? So now we're going to talk about the addition rule. So we're going to take the probability of 1 and the probability of 2 and add them together. So probability of 1 child or 2 children. So it's 22% and 41%. So we get 0.63. Again, if it says probability, you want to use the decimals. Don't use percentages. And then find the probability that the randomly selected mother does not have 4 or more children. So we're asking about the 4 children complement, or the complement of 4 plus children. So that's going to be 1 minus whatever this is. So for example, I'm asking, what's the probability that you're not in this group? If 13% is in this group, everybody else has to be in the other group. So we get 87%. Could you, in a pinch, have added those 3 numbers together? Yes. However, there are going to be times that there's going to be so many different separate probabilities, the complement's going to be your best way to go. All right. So with that being said, basic probability rules are yours. Ready to go, ready to rock. So if you have questions, drop them down below. Hit a like, hit a subscribe, whatever falls your way. We'll talk to you soon.